Hello everyone, welcome to this video. In this video, we'll be looking at an example which shows that group with a unique subgroup of finite order is normal. For this, we are taking a group which is the alternating group having A4, right? This is a group of permutations containing even permutations, right? And you know the order here, the order is 4 factorial divided by 2, so it is 12. So it consists of 12 rotations of the symmetry of the tetrahedron, right? We already studied in detail about this group A4, right? We have these 12 symmetries of this tetrahedron, and each of them is represented by these 12 permutations, right? All of them are even permutations. So if we are calling each of the permutations by the name alpha 1 to up to alpha 12, then we can very easily construct the Cayley table for it, right? This is the Cayley table. This we have already discussed in the previous video. Now looking at this Cayley table and looking at this alternating group A4, what can we say about this result here? Group with a unique subgroup of finite order that is normal, right? So let's have a look at this thing. So here you can clearly see that we can construct a subgroup H, right? So it consists of alpha 1, alpha 2, alpha 3 and alpha 4. Alpha 1 is the identity, right? Now we claim that this is a normal subgroup of the group A4. How? What is alpha 1, alpha 2, alpha 3, alpha 4? Alpha 1 is this, alpha 2 is this, alpha 3 and alpha 4, right? Now we are saying it forms a normal subgroup. When can it form a normal subgroup? According to the result, we know that if we take any permutation from this alternating group, right, then in that case we would have beta H beta inverse as the subgroup which is having order 4, right? And H is the only subgroup of A4 which is having order 4, because beta H beta inverse has the same order as that of the subgroup H, right? So therefore, and moreover its order is given to be 4. You can very clearly see that we have 4 permutations here, right? So we have both of them as equal. So by the above result, this becomes equal to this because they have the same order. We have H is as the only subgroup of A4 having order 4. Hence we say that A4 is normal, correct? Now we can also construct another subgroup. Let's say it as K, consisting of alpha 1, alpha 5 and alpha 9. Now this is not a normal subgroup of A4. Let's see why this is not there, because here we do not have a relation for every permutation taken from A4. We cannot define a normal subgroup such that we have the equality here for each of the cases. For each beta we do not have the equality here. So beta K beta inverse is not equal to K for every beta, right? So if that is the case, can we show that can we find some beta such that this condition is violated? Yes, we can. So here suppose we take this alpha 2 from A4, right? So we are taking this permutation from here. Now for this permutation here, we are saying if we apply it onto alpha 5, right, which is a member of K, that you know, this is a member of K. If we apply this alpha 2 onto alpha 5 and we have alpha 2 inverse, so we obtain alpha 7. How? If you see what is the inverse of alpha 2, let's have a look. We can have a look at our Cayley table. Here is alpha 2, right? We get the identity here which corresponds to alpha 2 here. So alpha 2 inverse is alpha 2 only, right? So this expression here becomes alpha 2, alpha 5, alpha 2. Now we need to solve this. So we first of all solve this much portion. So what is alpha 2 composed with alpha 5? Let's have a look. Alpha 2 composed with alpha 5, right? It is alpha 7. Sorry, it is alpha 6, right? So let's write down the value here. It is alpha 6 and alpha 2 as such. Now what is alpha 6, alpha 2? Let's have a look. alpha 6 is here, alpha 2 is here, so we have alpha 7 as the answer, which is what I have written here. But you see, we do not have this alpha 7 present in our subgroup K. Hence, this thing does not belongs to K when we take the element as alpha 2 from A4, right? So therefore, this condition is not true for every beta. Hence, this does not form a normal subgroup, right? So this is one example which suggests that group with a unique subgroup of finite order is normal and otherwise not. So I hope you understood this example well. Well, that is it for this video. Thank you for watching.